Welcome to Drafting and Design Center. In today's talk, I will talk about use of Civil 3D in a vertical profile. It is continuation of my earlier talk. The video has been uploaded and I have provided the link of that video underneath this description. So those of you who hasn't looked at it or hasn't or haven't had a time to go through it, please go through this video which is provided in description link. And this talk is continuation of earlier uh, earlier published video. So please go through that before going through this session. So in today's talk, we will discuss the use of Civil 3D in vertical profiling. As you can see that I have created a to explain the vertical profiling. I have used the example of subdivision development. As you can see on my cursor, the MC1 is defining this street, MC2 is defining this street. The both streets intersect here, and we will go through that profiling of vertical grading, selection of curve, including crest and sag curve, how we have designed using Civil 3D for this project. This is the horizontal alignment and cross section of MC1. MC1 is nothing but this center line of this street. So you can see here in this drawing, center line start from 0 meter all the way more than 220 meter. The road is 5 meter wide. Length, each lane is 5 meter wide, 3% cross slope with a barrier curb and gutter, and the verge is 5 meter wide, sloping 3% cross pole towards the top of the curb. And because of the drainage, we have installed or we have designed subsoil drainage in here, so that the water from capillary action can comes, get filtered in here and gets into here, and somehow there will be a discharge point along the all the way of or in somewhere else in here, as you can see here. So this is the what you can see here. Road pavement is in pink, the green is a verge here. MC1 is center line, curb and gutter both side. Total width of the carriageway is 10 meter. MC1 is the center line of the road. The legend is also provided. Similarly, I have rotated the slide. This is MC2. You can see the 20 meters zero start from the center line of the MC1. There is a point where MC2 and MC1 both intersect at here, which is 0 meter. All the way chainage goes to the 276.66 meter. Similar to MC1, MC2 cross section is 3% cross pole draining into the proposed curb and gutter, barrier curb, verge sloping towards top of the curb, and then subsoil drainage has been installed both way in here all the way along the road carriageway, which helps to discharge the water from infiltration, filters it, and then concentrate in a certain place into the design. While this talk is not about subsoil drainage, it is more about vertical grading. So I will emphasize more into the vertical grading side. You can see the legend here, proposed road pavement, verge, which is in green, and so As you can see, this one is new stormwater drainage. The one is in here with a lintel, all the way is defined. Civil line is also in there in red, which connects manhole in here all the way. This is civil line is here, all the way is turning and connecting to the existing civil line. So today we're gonna focus about grading of both MC1 center line and MC2. So as per my earlier video, I would like to go through the vertical curve. Based on Australian road design guideline, we need to provide the distance which called as stopping side distance, where the vehicle perceive the object, ongoing object, and reacts it and stop before it hits the object. So for stopping side distance, accordance with the Austroads geometric design of the road, based on a desirable value of deceleration and reaction and perception time, the distance is defined for 50 km road, which is always the speed limit is 50 km for urban subdivision road. So 50 km is the speed limit, and we tend to go for length of the crest curve from 48 to 62 meter, which is in this range. You can also apply for grade correction if you want to go more into detail. If it is crest curve having a 2% grade, you can subtract 2% from 48. So you can apply, you can add 2%, 2 point in here, so about 50 meter length. So always good to have vertical length of curve from 50 all the way to 62 meter, desirable minimum, which is equal to stopping side distance. Austroads geometric design of the road for minimum length of vertical curve is defined for 50 km is 30 to 40, and the minimum grade change required for crest curve is 0.9. As you already aware of, grade changes if the 2% is uphill and 3% is downhill, the grade change is about 1%. So there is a one grade and the next grade. So first grade minus next grade is a grade change. So minimum grade change requires 50, length of particle curve 30 to 40 minimum. So in other way, if we go for length of vertical curve, which is equivalent to stopping side distance length, that would be ideally okay. And this is what we have done in this example. Again, for minimum k value for sec curve for 1.1 meter height and 0.2 meter for 50, the minimum value of k is 5.2 to 6.8. You can also have k value which is from here, and then grade change you can get it from your profile, and you can define the length is equal to k into a. So that would be bit smaller than what required for calculation point of view, shall be a bit smaller than what the table provides. However, we go for a table, so 30 to 40. Rather than this, always good to have approach of providing a length of particular curve which is equal to stopping side distance. For sag curve, uh, needs to be designed for headlight side distance. The k value is equals to v square by 1296 times a. The value of v is the speed of vehicle, a is the acceleration, gravity force is g. So based on that, the k value is been defined. That comes if you put 50 km of speed limit, which is we have in this earlier example. So 50 square divided by 1296 times a, which is 0.05 times 9.81. The k value comes about minimum is about 3 or 4 if you calculate by yourself. So that is what k is defines the length of particular curve in a meter. So that is what the length of the vertical curve. However, for headlight side distance, this graph is provided. So road is 50 km and and this area is for low standard, and this area is other urban and rural road with a street lighting. So if I'm having a appropriate street light design, I will tend to go for this graph, which is 50k. Minimum value of that is about 9 or 10 for length of a sag curve. So we come from this table is good to have our crest curve length starting from 50, whereas sag curve is about 8 or 9, and based on that, the profiling of the MC1, as you can see that the grade is 2%, 3.2%. So the length of vertical curve is used as a 75, and then this is the MC1 where the connection road is MC2 is connecting here, where MC2 is profile is here, where MC1 is a connecting starting from here, and because of the intersection we need to provide 3% grade length initially. So this is what is being provided, 3%. It has to be 3%, and because this is sag curve, we tend to go for length which is 10 VC. As I said earlier, the length of the sag curve minimum is 8 meter based on the graph. So we have provided 10 VC is the length of sag curve, and the crest curve is comes to 50k, 50 meters, sorry, 50 meter. So this is the grading of MC1 and MC2. So basically we have I have talked about Austro design guideline for vertical grading. Minimum length of the grade has to be 1%, which is we have provided. Minimum grade value is 1%, which we have provided, and the crest curve criteria which I already described earlier, which is been applied to vertical profiling. You can also have a look at it, the video earlier provided, the description is provided below. And lastly, at the intersection there is a curve return. So as you can see here is MKR02, this is this one, MKR01, this profile is this one. So we need to make sure that the curve return has to be having a radius of more than 10 meter, because the vehicle has to come out and go in, and because at that portion we expect the vehicle to decelerate and then turn it, so the speed has to be less than 50k or 40k. It will be about 10k or 12 kilometer per hour. So for that at least we have to provide VC is provided is about 11 meter length of vertical curve, and as you can see here is both 11 meter vertical curve with horizontal radius of 13 meter is proposed to be provided, so the vehicle can enter it without going into the different lane, enters into the dedicated lane. And this was the design of the intersection. Vertical grading of intersection was adopted. Once again, thanks for watching the video. If you like, please subscribe the channel.